Hello, good morning. I am audible.
Yes,
Yes,
sir.
sir.
Okay. Okay. So today, as I told you that today I will discuss about the double integral. In fact, it is multiple integral and start with the double integral. And if possible, few examples will be given later on triple integral, but mostly we will discuss about the double integral. So it is almost the similar thing as you have done the definite integral for the function of single variable, but here not on a over a line. Here it is over an area. Just a moment. So first I will discuss what is the double integral, then different properties, some types, and then some problems. So first look at this. Here double integral. Here the function is a function of two variables that we have considered here as a function fxy. Fxy be a continuous function of two independent variables. Here x and y are the independent variables inside and on the boundary of a region R in the xy plane. This is the xy plane, x-axis, y-axis, and suppose this is the first quadrant. It is not necessary that we have to consider the first quadrant. We can do the integral over any portion of the plane. But here, just for example, how to derive the double integral. That's why I have taken this one. So this is x-axis and this is y-axis. And suppose the region R is this one. It is considered as this region, and we have to integrate the function fxy over this region. So R inside and on a boundary of a region R in the xy plane. This region is R. This region is R. Now what we have to do, as in your in case of the function of single variable, you know that if the curve is this, then it is divided into several small strips, and then we integrate, then take the limit, and then uh, if this thickness is h, we consider h tends to 0, etc. in case of the function of single variable. Here we are considering actually the area. So now look at this. Divide the region R into subdomains R1, R2 up to Rn. That is, it is divided in this way. In this way. So if you consider this total region is divided into subdomains like this one, this portion 1, this is one subdomain, this is another subdomain. In this way, it is divided into several subdomains like R1, R2, up to Rn. And suppose their areas are delta R1, delta R2, delta Rn, small elementary region respectively. And let us consider one general subdomain. Say suppose this is one subdomain, and we consider it is as delta Ri. And let any point, suppose this is the subdomain, and this area is delta Ri, and let us take any point in this subdomain as xi, yi. So the functional value is what? F xi, yi. Now, if you consider this functional value f xi, yi into the area of this region, the functional value into area of this region, then we will get this one. Now, how many subdomains are there? N subdomains are there, R1, R2, up to N. So total area will, summation will be what? Summation I equal to 1 to N fxi yi into del Ri. But here we will, suppose if you take a subdomain like this, if you take any point here, and you are considering that sum is fxi yi into delta Ri. But this summation is done only when if you take the elementary area, that is R1, R2 up to Rn, the areas are delta R1, delta R2 up to delta Rn, very small. That is when n tends to infinity. That is, if you divide the region R into subdomains, infinite number of subdomains, so that each area becomes very small. And in that case, when n tends to infinity, actually your area of each subdomains tends to 0. Area of each subdomain tends to 0. In that situation, that is when delta Ri tends to 0, that is when limit n tends to infinity Sn, delta Ri tends to, that is when you are taking limit n tends to infinity. So if this limit exists, limit n tends to infinity, Sn equal to this, and if you take limit n tends to infinity, that is the region is divided into infinite number of subdomains, means the area of each subdomains is tends to 0. Then if this limit exists, then we say that the sum of this is taken as the double integral of fxy over the region R. So one thing must remember, that if this limit exists as n tends to infinity, it means it is nothing. It is means that you are taking the interval, not here interval, you are taking the subdomains are very small. Almost its area tends to 0. That is written here, delta Ri tends to 0. And in that case, if the limit n tends to infinity Sn, means if in that case, if this sum exists, then it is denoted by this double integral. So at each time when I will give you one problem that solve this integral or find the area of the integral value over this region, you will find the sum and then you will check the integral value. No, this is the derivation of the double integral. Now we can use this, that is when our delta Ri tends to 0, if this limit exists, then double integral exists, and this double integral is this, its value is this. So if I give you any problem, you have to solve this one on double integral. That is that this is the double integral. This is the symbol double integral. If it is triple integral, then this one. And this integral is done over the region R, over the region R. That's why it is written R. The which function is integrated over the region R? Fxy, and delta dr means elementary area, as you consider in case of the single variable dx, and here it is considered as dx dy. How dx dy? If dx dy be the length and breadth of the rectangular meshes, then dx dy is an elementary area. That is, if you consider elementary area like this, any general area, its thickness is this and height is dy, then dr actually what? Dr is dx into dy. So this integral r fxy dx dy, dr equal to integral over the r fxy dx dy. So finally, ultimately, we have to solve this one. But how it is derived, this double integral, that is explained in this portion. It is, if you compare with your definite integral in case of the single variable, it is almost the same thing. Only in case of the single variable, it is considered as the uh, uh, length, because it is considered on a line. So it is length. Here it is divided into this. So you consider here sub-regions. Region is divided into several sub-regions. With each sub-region, we take a point, we evaluate the function, multiply by this, by the area of this sub-region, taking the sum, and then you have to consider these sub-regions as very, very small. That is, we are taking n tends to infinity. N tends to infinity, nothing. It means we are dividing the region into infinite number of sub-regions. Infinite number of sub-regions. So that area of each sub-regions is very, very small. And that is this one. And dr is written here, dx dy, because it is considered in the xy plane. If each sub-region, suppose if you consider a general sub-region is r, dr, then its if its thickness and height is dx and dy, then it is dr equal to dx dy. So finally you arrive to this integral r dx dy. Is it clear?
Yes, sir.
Okay. So we'll move to the next one. How to evaluate the double integral. First, we have derived the double integral. Now we will check how to evaluate the double integral. It is not that all, as I told you, that it is not like that you have to, for a given problem, you will divide it into sub-regions and then take limit. It is not. We have derived the formula that this is the double integral for a function over a region R. Now, how to evaluate this double integral? So, two main possible ways to evaluate the double integral rfxy dx dy. This one, mainly two possible way, but there are sub cases for these cases also. First, look at this. Just a moment. First, look at this. Let R be expressed in the form r equal to fx xy, that is r is the region, and y varies from phi x to phi psi x, and a varies from a to b. What is the meaning of this? What is the meaning of this? Region R over which you have to integrate the function fxy, that is R, and that is defined in this way, that is y varies from phi x to psi x and x varies from a to b. And next problem, look at this, rfxy, x varies from gy to hy and y varies from c to d. Do you have any clue for this type of regions, that what actually it means, that y varies from phi x to psi x and x varies from a to b?
Sir, can I ask something?
Yes.
Sir, this is the area of this part,
Hmm.
but we conventionally till this we used to find this area by minus,
Hmm.
like integral of psi x minus integral of phi x. Then we find the area. Then why should we use, sir, double integral?
Uh, I could not understand. In case of the you are actually meaning the for the function of single variable or what?
Sir, for single variable.
No, no. Double integral. Suppose in case of function of single variable also you can use the area, but here actually we are not evaluating always the area. Here also we can evaluate area. Suppose r dx dy, then it is the area. Okay, so here also you can evaluate, but actually when you are, just go back to this, when you are evaluating this one, it does not mean you are evaluating area of a region. You are evaluating this integral means evaluating the integral of fxy over a region, not a over a line. This is not the actual the area. Remember this. This is not the area. I will give you some example on area where you will understand that how to evaluate the area. You are meaning that using function of single variable also you can find the area. But actually this means, it does not mean that it is the area. It is the integral of the function fxy over a region.
Okay, sir, understood.
Okay, but here actually how these two types of integral, mainly these two types of integral, there are many sub cases are there that will be discussed. How you will evaluate these type of integrals? When in case one, y varies from phi x to psi x and x varies from a to b, and in case two, x varies from gy to hy and y varies from c to d. Actually, I am asking that in suppose forget about case two. In case one, actually what is means about the area? Area is given here, that R, a pair of points, because we are considering two words. Here we are not evaluating area actually. We are evaluating the integral of the function fxy over this area. Now my question is, what does it mean? It means that in this area y is a function of x, but x, here look at this, x is not a function of y. X varies from a to b. A and b are constant. Suppose here look at this. This is one curve y equal to phi x. This is another curve y equal to psi x, this one, and from this point x equal to a, here x equal to a, and here x equal to b. So here actually the area of integration is this one. But look at this. If you consider suppose this one and this one, then say x equal to a, x equal to b, and y equal to c, y equal to d. But it is not a square or rectangle, it is a curve. So here y actually function of x, and at any case, at any place, at any place, suppose if you consider this point, then here y varies from this to this. If you consider y varies from this to this. If you consider here y varies from this to this. So at each point y is a function of x. So in that type of case, we have to first evaluate y, then x. First evaluate on y, then evaluate on x. Similarly, you are getting me?
Yes, sir.
Okay. Sometimes you will respond, and sometimes it is found that I have disconnected from the recent times it is happening. Even I have two network system is open. Still it is found that sometimes I am disconnected. Okay, in the second case, here x varies from gy to hy. Suppose this curve x equal to x equal to hy, and here this curve x equal to gy. So at any place x varies from here to here, x varies from here to here, x varies from here to here. So suppose if you consider here to here, means here x equal to what? X equal to gy. Here x equal to hy. You cannot say here x equal to certain value, here certain value. No, it is, since it is a curve x equal to gy, since it is a curve x equal to hy, at each point x is gy, x is hy. And here from this to this, because here y equal to c, y equal to d, y is constant, but x depend on y. Here in the first case, y depends on x, but x is constant. So in this type of integral, we have to first evaluate the variable limit. Since y varies from phi x to psi x, so first we will evaluate this one, then x, because limit of x is constant, a to b. Otherwise, you will not get the limit of this function. Similarly, in case 2, first you have to evaluate. Look at this. In this case, first you have to evaluate the x integral, then y integral. So these are main two types. Then you can ask me that if both x and y are constant, suppose x varies from say a less than equal to x less than equal to b, y less than equal to c less than equal to d. Then what? First x or first y? It depends on your choice. If you think that if we integrate first x, it will be convenient to integrate, then y, you can do it. Or if you think that first y is convenient for you, then x, you can do it, no problem, because the integral are constant. But when the one variable depends on the other, then that integral must be done first and next constant integral second. So remember this. Any question?
No, sir.
Just a minute. হ্যাঁ আমি ক্লাসে আছি, বলো। তুমি পাঠিয়ে দাও না, একবার একটা কপি আমাকে পাঠিয়ে দাও, আমি দেখে নেবো কোশ্চেনটা। সেটা ওতে অসুবিধা কিছু নেই, তুমি তো, হ্যাঁ হ্যাঁ, তুমি একটা কপি আমাকে সিসি করে দেবে। হ্যাঁ হ্যাঁ, ঠিক আছে, ওই পিডিএফ করে পাঠিও কিন্তু। You have any question? In the first case, why this first integral with respect to y, in the second case, y with respect to x first, then with respect to y. Is it clear or not?
So please repeat.
Clear, sir.
And uh, and in case of the constant limit, say here as it is mentioned here, that x varies from a to b, y varies from c to d. In that case, it is depends on you. Completely depends on you, which integral to be first, which integral to be second. But sometimes it is found that depending on the function fxy, we observe that if we do first with respect to x, it would be better instead of first doing with respect to y. But in some cases, it is found that if we do first with respect to y, it would be better than if we do first with respect to x. So it is depends on your choice. But if there is one limit is variable, then that variable limit must be done first and the constant limits in the last. In case suppose you are considering a three-dimensional three triple integral. In that case also, if the variable limits are there, variable limits must be done first, then the constant limit comes. So if you have any question, you may ask me. Otherwise, I will show you some more properties and types. Okay, so this is that I have discussed. When we will solve integral, if you have any question, you may ask me at that time also. Just a minute. Okay, now that if region R is fxy, all xy, which type of xy? X varies from a to b, y varies from c to d. In that case, look at this: R fxy dxy equal to c to d fxy dy, a to b fx dx, or c to d a to b fxy dx and then dy. It depends on you. Both are same. It is for constant limit. And as you have done, you know some properties of the definite integral. Here also some properties for the double integral. Simple properties. Suppose look at this. In this case, here k is a constant. So k is independent of the limit. So you can take k outside the limit. K is a constant. Suppose 5. So you can take it. Where is you know it still. And suppose function is fxy plus gxy. That is over this region. This is R. two functions fxy and gxy to be integrated, fxy and another function gxy to be integrated over this region. Then r fxy plus gxy dx dy equal to r fxy dx dy gxy dxy. This is also true for function of the single variable. If the region R is partitioned into two subregions R1 and R2, then R fxy dx dy equal to R1 fxy dx dy plus R2 fxy dx dy. It is also true, you know, that in case of single variable a to b and here it is c, then a to b means a to c, c to d. Sorry, C to B, C to B. Here also, if the region R is divided into two regions, R1 and R2, and if the function fxy, then fxy over the region R means fxy, integral of fxy over this region plus integral of fxy over this region. If the region is divided, sometimes it will be useful that the region is so complicated. In that case, we can use these properties that we can divide subregions, integrate the function over each subregions, then we can take their sum. Okay. Just this is very important property. Change of variables in double integral. Change of variables in double integral is very important because in case of single variable, it was very simple. Suppose if you consider a substitution, say, just a moment. If you consider a substitution, say x equal to sine theta, you know that it is dx equal to cos theta d theta. Just substitute this one and then integral will be changed and limit will be changed and you can integrate it. But what will happen in case of the function of double variable or double integral or triple integral also? This change of variables is very important, very important. uh, Often it is required to change the variables in double integral. That is, the given integral, it is sometimes not possible to integrate or may be difficult or will take more time or will be very lengthy. But if we give a suitable substitution, then the integral becomes simple and we can easily evaluate it. Suppose our variables are xy, fxy. We have to evaluate this one. We are a substitution is given here, x equal to x uv, y equal to y uv, means the new variables are uv. I will show you some examples also. X equal to x uv, y equal to y uv. So this integral, after this transformation, this integral will be transformed to another integral. What will be that? If xy varies over this region, then after the substitution, area will also be changed for the new variable. As you know that if you substitute x equal to sine theta and x varies over this region, then area will also be changed for the new variable.
Hello, sir. You are not audible.
Hello.
అదే
Hello, I am audible,
Yes, sir.
but I was disconnected or not?
Yes, sir.
Yes,
You
sir.
were.
Yes, sir.
Oof, I could not understand what happened. Just wait. This change of variables I have discussed, or before that was disconnected.
Yeah, before that.
Before that,
Just
sir.
Before that,
started, sir.
just started and then disconnected. Sorry. Now look at this change of variables in double integral. Here, uh, that I told you that in case of the function of single variable also, sometimes you give the transformation so that your integral would be easier to evaluate. Say in some cases, suppose if you give a transformation x equal to sine theta, then for the variable x there is a some limit, and that limit will be converted to theta, and the integral fx will be in terms fx will be some function of sine theta, cos theta, etc. And dx is what? Cos theta d theta. But that is for the function of single variable. In case of function of double variable, triple variable, etc., that is multiple integral. In case it is not like that. You can give a transformation, say x equal to x uv, y equal to y uv. That is your system from xy coordinate system, it transformed to uv coordinate system, uv. It is just an example that x equal to x uv, y equal to, say for example, x equal to u plus v, y equal to u minus v. This is the transformation. In some cases we give this type of transformation also. Since you have given new coordinate, so this region R in the xy plane also will be changed to region R dash in the UV plane, R dash in the UV plane. And this function fxy, now it is a function of UV. And what will be the dx dy? That is very important. That dx dy is actually mod j du dv. Mod j means what? Mod j is the absolute value, that is modulus value of the Jacobian. Modulus value of the Jacobian. And this Jacobian is nothing. This, look at this Jacobian is del x del u, del x del v, del y del u, del y del v. You have to evaluate this one. And if it is, say, for example, its value is negative, then you have to consider only the positive value. If its value minus 5, you will take 5, because here mod j into du dv. So whenever in two-dimensional case, three-dimensional case, four-dimensional, two-dimensional, three-dimensional, any multiple integral, if you give any transformation, then you have to evaluate the Jacobian. If it is three-dimensional case, then what will be the happen? Then del x del u uvw. Suppose x uvw, y equal to y uvw, z equal to z uvw. Then del x del u, del x del v, del x w. In this way, you will get a 3 by 2, 3 by 3 determinant. So whenever you will give a transformation, you have to evaluate Jacobian, remember, and here you will consider the mod j. Here it is written, look at this. The integrand is expressed in uv and dx dy is replaced and by the modulus of the Jacobian times du dv. Modulus of the Jacobian times du dv. and region R in xy plane is transformed to the region R dash in the UV plane. As if you consider say x equal to sine theta in one dimensional case, limit of x will be changed to the limit of theta. Here also limit of xy will be changed to the limit of UV. That is here actually the region R in the xy plane transformed to the region R dash in the UV plane. Okay, next just one example is given here. Look at this. That very popular transformation, you know that from when we move to Cartesian to polar, here look at this, x equal to r cos theta, y equal to r sin theta, and in that case Jacobian is del x del r, del x del theta, del y del r, del y del theta, that is cos theta minus r sin theta r cos theta, that is equal to r. So in that case dx dy will be r into dr d theta, and if the region is r fxy dx dy, that will be r dash f of r sin theta r cos theta r dr d theta. So whenever you will give a transformation, you have to evaluate the Jacobian. Okay, so again we will start 10 minutes. After 10 minutes, then we will solve some example also. Okay, so we will start again after 10 minutes.
Sir,
Yes.
sir, last class only one period was taken, and in between that you were disconnected. So Lagrange's
Hmm.
multiplier was not completed. Uh, so
But again, I have joined and discussed. Okay, if you need, then I will discuss. No problem. First, I
yes, sir.
finished
Thank
it.
you, sir.
Again, I will discuss. I hope that I will get time to discuss if you have any queries regarding earlier that I have discussed.
Okay, sir. Thank you.
Because I in the next class, first class, I will take one class test, and then 1 hour I will again discuss the multiple integral, and after finishing this, then I will discuss what about your problem, solve some more problems. So I think it is not any problem.
Okay, sir.
Okay.
Yes, sir.
Mm. Okay, so we will join again after 10 minutes. Now I am quitting from the classroom because I have to download one more PDF. Then I will again join after 10 minutes. Now audible?
Yes, sir.
Yes, sir.
Okay, okay.
Excuse me, sir.
Yes.
Sir, can you please repeat about the exam?
Repeat about what?
The exam, what you said? Class test.
Okay, okay, okay. I'm asking. You. Okay. As I told you in the earlier class that in the next class I shall take on class test. And class test first I have decided that in the next Wednesday I shall take the class test. First hour for the class test and second hour as usual I will take the class. So it may be for half an hour class test. Mm,
Sir, syllabus?
20 syllabus if you have any suggestion you may give, otherwise I will decide. If you discuss together and send me that we would prefer this portion, then I can give you, no problem.
So, how many chapters?
Or how many chapter, it does not matter. They decide. Maybe I will give you the four questions, and for all four you have to attempt, because class test usually no alternative is given. You may consider the function of several variables, the uh, function of several variables, so function of several variables, uh, excluding maxima minima, because in the midterm we have not considered function of several variables, so it will be a practice for you for the final, if you
Sir,
decide. Otherwise, you can.
sir, in maths we have three professors, so every one of you with a different class test.
No, only I will take the class test.
Okay, sir.
Sir, we have offline
Okay.
class from 21 March.
As I know, already it is notified. And if you maybe your final exam in which time? April,
Yes, sir. 7 to 13 April.
7 to 13 April. So before that, I have to finish. It is okay, no problem. But in the next class, I have decided to take the class test because later it may be difficult. Just a moment. হ্যালো, হ্যাঁ হ্যাঁ চলে গেছো? না না না, ঠিক আছে, রাখ। Okay.
Sir, class test full marks and time.
Full marks and time, it depends on you and me, because it is totally depends on the concerned teacher as per our ordinance. So I have decided that as I have to give 20 marks, so I will take the class test on 20 marks. Otherwise, if I take 15 marks, then I have to convert it again 20 marks. If I take 25 or 30 marks, then again I have to convert it to the 20 marks. So instead of that, I have decided that I will take the class test on 20 marks, and four questions will be provided, and you have to attempt the four questions, and maybe half an hour. Half an hour, if you would like, then I can give you 40 minutes, because within one class I have to finish that.
Okay, sir.
Okay. So you can decide. Otherwise, I am thinking to the syllabus as the function of several variables, excluding maxima, minima, multiple integral.
So if
Okay,
we
sir.
decide, then when we have to inform you within today.
Uh, Not today. Maybe within 2 3 days you have to decide yourself and send me one mail.
So then our CR will inform you.
Yes,
Yes,
sir. In the
to
classroom,
share.
sir, we will post.
Yes, in the classroom you have to mention it and by your CR.
Okay, sir.
You can decide together, no problem. But
Okay, sir.
and
We
if
decide and
you
our
don't
CR will
send,
inform you.
okay.
Okay, sir.
So
Sir, only one
so
chapter we have to
now
decide.
Sir, multiple integral will not be a part of the syllabus, right?
no. Multiple
Okay, sir.
because it is now I am discussing, so I think it is, and also I would not consider the what maximum Lagrange's multiplier. I am not giving only the if you. I have decided that function of several variable except multiple integral and maxima minima uh, Lagrange's multiplier. Still, if you would like to change, then you can do.
Sir, what you are wanting, sir, we are fine with that.
Fine with that? Okay, then it is
Yes,
okay.
sir.
Because I am excluding multiple integral, I am excluding uh, maxima minima, Lagrange's multiplier, because some of you have some doubt on Lagrange's multiplier.
So
So
specifically
I
the
am
syllabus, can you
excluding.
post in the classroom?
Then again, I have to not with me. Then I can yes, I can post you.
Okay, sir.
But if you agree with me, then otherwise you will inform me in the classroom that we have decided your
Sir, we are
class
agreeing with you.
representative.
Yes, sir. We are agreeing with you.
Oh, okay, then no problem.
Yes, sir.
And sir, will we have the end sem in offline?
Yes, as our
And sir,
notification that
will it be held like on the previously decided date? Because like 10 days after college reopening, like it will be difficult for us to give the exam.
that may be changed. I don't know, but as our notification is made, it is mentioned that from 21st March, all classes, everything, class, final exam, everything will be offline. So if you have any question or anything about your offline purposes, then through your Senate representative, you can raise the question. You know there is one Senate representative, two Senate representative from the student side. So through them you can raise the question. It is many times it is happened in last 2 years. Many times it is happened. Different questions. If you have any question, you can also through your class representative send the mail or call your Senate representative. Then they will inform the authority. Then accordingly it will be decided.
Okay, sir.
Okay. Hmm. Okay. Okay. So next, what I have discussed. Oh, change of variable Jacobian. Okay. Next, that will be very important. Order of integration. Order of integration. Order of integration is also change of order of integration is also very important. In some case, in sometimes it is happened that I have also mentioned earlier that if we do first with respect to x, then with respect to y, it may be convenient that if I do that integral first with respect to y, then with respect to x. Sometimes it is happened, and in that case, it will be easier to evaluate. So I would give one example. Look at this. This example is here. Evaluate R fxy dx dy, where fxy equal to xy function is given, and R is the region bounded by two axes and the line x plus y equal to 1. X plus y equal to 1. In that case, if it is possible, in that case, it will be better for you to draw the area of integration. Here look at this. R is the region bounded by the two axes. So this is x axis, this is y axis, and the line x plus y equal to 1. So this is x plus y equal to 1. So the area of integration is what? This area, this area, this is the area. Then it is better to change, then it is better to try to you can check whether sorry, whether it would be better with respect to x first, then with respect to y, or with respect to y first, then with respect to x. Suppose, so in that case, when you are going to change the order of integration, not the change of variables. Remember, one thing is the change of, just a minute. You are getting some noise, no? Hello,
Yes, sir.
No, sir.
are you getting noise?
No, sir.
Certainly, here started one work, and I am also getting noise. Okay, I am trying to another place. Okay, so here look at this function fxy. So sorry, I was telling that change of variable and change of order of integration. These are two different aspects. Change of variable means that I have discussed that when you will change, then you have to evaluate the Jacobian, and that will be multiplied by the new variable. Say if you new variable uv, then it is Jacobian into dx dy equal to Jacobian into du dv. And here it is not the change of variable, here it is the change of order of integration. That is, first we will do the with respect to x, then y, or first with y, then with respect to x. But for change of order of integration, you have to draw the region of integration. Otherwise, it is very difficult to change the order of integration. So, for example, here one example is given, but no, not this is the example of the change of order of integration. No. Later I am giving the change of order of integration and change of order of change of variables. Here it is, this example is not the change of order of integration. It is just an integral. Okay, later I will give you. But in that case, change of order of integration, you must draw the figure for the region of integration. Otherwise, it will be difficult. Okay, let us take one example. This is not the change of order of integration. It is just an example how to evaluate the double integral. Here, fxy equal to xy, R is the region, and this is the region of integration. Now tell me, this is the given integral fxy dy dx or dx dy. It does not matter. Then R is what? R is this region. This is the region R. And fxy equal to what? Xy. Dx dy or dy dx, you know it. Now check the limit of integration. Now check the limit. Now check the limit. Look at this. First you are taking with respect to y. if you take with respect to x, no problem. But as we are taking first with respect to y, check here. First with respect to y means y varies from any, take any point here. First y from here to here. So here y equal to 0, and in this line y equal to what? 1 minus x. So y equal to 0 to 1 minus x. And x varies from 0 to 1. But if you take first with respect to x, then you have to consider here x from 0 to here, that is x is 0 to 1 minus y, and in that case y varies from 0 to 1. So it does not matter for this integral whether first with respect to x or first with respect to y, but in some integral it matters. Just check the limit, whether the limit is written correctly or not. Why it is written y equal to 0 to 1 minus x? Is it correct? Why is written 0 to 1 minus x? Because y varies from 0 to this point. If you take y here, y varies from 0 to this point, but any point on this line is y equal to 1 minus x. That's why it is written 0 to 1 minus x. So you are evaluating first with respect to y. In that case, x is constant. So x is constant, and y equal to integral of y is y square by 2. That is 1 minus x by 2. X square by 2, and x is constant. So the next integral is x into 1 minus x square by 2. Then with respect to x, then you have to evaluate this, and after this is 1 by 24. It will be easy if you do this step. Then from this step it is nothing, it is function of only the single variable, because already you have evaluated the integral with respect to y. So my question is whether this limit is clear or not, that list y varies from 0 to 1 minus x and x equal to 0 to 1 minus y. This limit is clear or not?
Yes, sir.
Yes, sir.
Okay. Suppose any one of you that I will do first with respect to x, then with respect to y I will do first with respect to y. No problem. In that case, the variable limit will be considered first. Variable limit means here x, you are doing x first. So your limit will be x equal to 0 here to any point on this line. Any point on this line means x equal to 1 minus y. In that case, it will be x equal to 0 to 1 minus y. Here it is xy dx first integral, and y will be 0 to 1. Y is 0 to 1 dy. You will get the same thing, 1 by 24. This simple integral, it is no problem whether you are taking first with respect to x, then with respect to y. But in some cases, you will see that if you consider first with respect to y or first with respect to x, it will be easier to evaluate the integral. Okay, so next integral. Oh, it is also given the change of order of integration. Here it is first with respect, sorry, here with first with respect to y. Yes, this example also. Here it is first with respect to x. but the same thing. Okay, it is not so simple integral, that's why it is no problem. Okay, this note is very important. To change the order of integration, first draw the region of integration. That I told you, that whenever you are going to change the order of integration, first draw the region of integration. If you cannot draw the region of integration, then it will be difficult to change the order of integration. This is very important. So change of variables, you have to evaluate Jacobian. Change of order of integration, you have to draw the, it is not compulsory to draw the region of integration, but if you do not draw the region of integration, then it is practically impossible to change the order of integration. Okay, next example is this. Evaluate y dx dy, where R is the region bounded by x-axis, y-axis, and the portion of the circle x square plus y square equal to 1 in the first quadrant. Evaluate this one, but only the region of integration is a portion of the circle in the first quadrant. Look at this one. This is the circle, but here only we are considering the first quadrant bounded by x-axis, y-axis, and the first portion of the circle in the first quadrant, that is this portion. This portion. This is the region of integration. So here x square plus y square equal to 1, any point on this circle. Here look at this. Since this region of integration is bounded by circle, usually when it is circle, we usually give the transformation x equal to r cos theta, y equal to r sin theta. In that case, Jacobian equal to, already I have given one example, this Jacobian is r. And what will be the region of, region of integration is this. Then now this r dy dx equal to what? First of all, y means r sin theta, and dx dy equal to what? Dx dy equal to r dr d theta. So it is r square sin theta dr d theta. Now, if you consider in polar coordinates this circle, this portion, then theta varies from what? Theta varies from this, in this line theta is 0, and in this line theta is pi by 2. Theta varies from 0 to pi by 2. And r varies from what? Its radius is what? Radius is 1. So r varies from 0 to 1. R varies from 0 to 1. 0 to 1. So its value is 1/3. Now you can ask me that if I don't give the transformation, is it still is it possible to evaluate or not? Yes, still possible, no problem. In this problem it is possible, and but look at this, if you give this transformation, it becomes easier to evaluate. And if you ask me that if we don't give the transformation, how it is we set the limit, then look at this. X varies from what? So, sorry, if you are considering first with respect to x, then with respect to y. I am also considering first with respect to x. You also, we may consider first with respect to y, no problem. Okay, if we do not give this variable transformation, change of variables, then look at this, how you will evaluate this one, the given integral, that is equal to x equal to y equal to, say here it is dx dy, and y, and sorry here it is x, y. Can anybody tell me any idea what will be the limit of x and what will be the limit of y if we don't give the transformation, variable transformation? Any idea? Because I have already draw the circle.
Sir, 0 to 1.
0 to 1 minus
Which,
x square whole under root.
Yes, sir. Yes, sir.
which
0
one?
to 1 minus y square का root.
For x or y? I
For
have
x.
For
written
x.
x first, then y. So tell me what will be the limit of x? Yes,
0
it
to
is correct that
1
x equal to 0 to
Under root
0
1
1
minus
to
y square root.
under root 1 minus y square.
yes, yes, root over of 1 minus y square. Why? Because here x square equal to 1 minus y square. So x equal to this. We are not taking negative sign because it is in the positive quadrant. So x equal to 0 to 1 minus y square dy dx dy, and y is varies from 0 to 1.
1.
0 to 1. So you can also evaluate this one, no problem, you will get the same thing. But for this simple problem, it is okay. It is if even if you do not change the change of variables, then also you can evaluate this one. But in some problems, it may not be possible. It is not like that may not be possible means very complicated. You can evaluate it for every integral without giving the change of integration may be possible, but sometimes it becomes truly difficult. As in case of the single definite integral, you also know that if you give a some transformation, it becomes very simple, x equal to tan square theta or x equal to t square, then it becomes easier to evaluate, but otherwise it is not possible to evaluate the integral. Here also, even if we do not give this transformation, then also we can evaluate, but it becomes easier. And one thing you must remember that this change of variables, whenever you will consider the Jacobian, but you will take the modulus value of the Jacobian. Here it is R positive, so we have not considered any modulus value, but if you get any negative value, then you will consider only the positive value. This is one thing you must remember. Okay, I will give, if you have any question you may ask me, otherwise I will give two more examples before have any question? Otherwise I will show you another okay.
Sir,
Yes,
sir, I have a problem in set 6 of several variable.
which problem?
Sir, set 6 first page only. It was some basics problem, I think.
I have to check whether set 6 is here or not. Otherwise, set 6.
Yes, sir.
Set 2, set 4, set 5. Set 6 is set 6.
Sir, like I am facing that the meaning of fxy and the
If
in the differential coefficient form.
differential coefficient form, is it not available here? Do you have the that PDF with you?
Yes, sir.
You can share.
Sure, sir.
Okay, then I am stopping. Share it. I am checking.
Okay, sir.
Just I am stopping the sharing. Okay, share it.
So like here.
But not showing. Sometimes showing. Now it is not showing in the screen.
So now.
Now showing.
Okay.
Which part? Which one?
Sir, this one.
This one means which?
Sir, fxy and fyx. Sir, this definition, sir. Sir,
Just a moment. Fxy and fyx. Oh,
yes,
okay,
sir.
okay. Yes. What is your question?
Sir, like in fxy, sir, first we need
Hmm.
to partially differentiate with x and then y.
Fxy. Yes.
Sir, and what is the meaning of this one, sir?
First, with respect to x, actually, when I had discussed, I told you that uh, fxy, that is first with respect to x, then with respect to y. Fyx first with respect to y, then y, then with respect to x. In general, not equal. That is, it is not a general conclusion that fxy equal to fyx.
Hmm.
But if any one of the fx or fy uh, are continuous, sorry, fx, fy are continuous, then and any one of this what is fxy or fyx continuous,
Hmm.
then it is possible. Then these are equal. The meaning that suppose fxy is a function. Okay, then your move
Sir,
from the
actually, sir, I
screen.
was, yes, sir.
I your stop your screen. I will
Sir,
discuss
one
now.
more problem, sir. Actually, I was reading from the internet, Google. Sir,
Hmm,
it was
hmm.
showing that del to u upon del y into del x.
Del.
Del to u upon del y
Hmm,
into del x instead of
hmm,
del
hmm,
x into del y.
hmm,
Sir, can I show you that one?
hmm, hmm.
Sir, here, sir.
Oh, it is written in this way. It is not the written that I have written. It is correct. I am just explaining that fxy or del square f by del square f del x del y. It is correct. It here. Okay, stop your screen. I will write something.
Okay, sir.
Hmm, okay. Uh, just. Hmm. Here that you are mentioning that del y del u del x. Suppose this one, it is actually del y del x. It is okay, no problem. And what you are as I consider that your question is just একটু পরে দেখো fxy means first with respect to x. and first with respect to x, then with respect to y. It means suppose fxy equal to x square plus y square plus xy. Then fx means what? 2x 2x plus y, and fxy is what? 2x. And fy is what? First if you do fy means 2y plus x, and fyx is what? Sorry, here it is a mistake.
FXY will be
It is
1.
sorry. Here it is 1.
Yes, sir.
Fxy 1, and fyx this is also 1. So look at this. Here fxy or fyx, that is first with respect to x, first with in most of the cases it is happened that both are equal. But you cannot draw any general conclusion. I told you that in some cases it may not happen, and I also, as I could remember, that I also give you some example where fxy not equal to fyx, but probably I I have sent you the PDF or not, I could not understand. But so if there exists any one, at least one, then you cannot say any general conclusion. Your internet is written in this way. That's del y of del u del x. It is written in this way. But remember this, you can, it means you are differentiating this with respect to y, and it means you are also differentiating del u del x with respect to y. Both are same, but this symbol is used instead of usually we use this symbol in most of the books, and it is continuing that in this way we write in this way instead of writing in this way. When we define that it means the derivative of this with respect to this, then we write in this way. But when we suppose I am discussing with you, I am trying to trying to teach you that this means this, then we write in this way. But otherwise we write in this way. If I don't discussing with anybody, or I am just calculating writing this, then we write in this way. So it does not matter whether you is writing this or this, but remember that also you have seen that in many problems we have assumed that fxy equal to fyx, because otherwise your answer will not come. In that case we assuming that fx, fy, these are all continuous. So we are assuming that. But still, it is not general. In some cases, many examples, there are many examples where fxy not equal to fyx. That is, if you do the derivative first with respect to x, then with respect to y, it is not equal to first with respect to y, then with respect to x. But your writing, I would suggest you write in this way. This is the most used symbol used for the partial derivative. Use this symbol, and if you prefer, uh, then you can write also this, because it will be little lengthier, it will be easier. Both all are same, nobody will cancel your answer and anything. But
Hello,
in your
sir.
question, in your question, if it is given that del u, prove that del u del x equal to this, then I would prefer to write in this symbol instead of this symbol. Yes.
Hello, sir. If x and y power is different, then fxy and fyx is not equal to.
Not equal to, that's why I telling you that it is not always equal. So you cannot draw the general conclusion that fxy equal to fyx. In some cases it may be possible, but it is not always possible. So never you will not draw the conclusion that fxy equal to fyx. But what will happen? I have told, I have solved some example, say using uh, Euler's theorem, that x del square u del x square plus 2xy, 2xy del square u del x del y plus y square del square u del y square equal to something n into n minus 1 into u. I prove this, but whenever to come to this part, we have used del square u del x del y equal to del square u del y del x, because first we have discussed derivative with respect to x, then it is multiplied by x, and otherwise you will not get this 2 into this one. So here it is assumed that this one, otherwise your answer will not come. That's why it is used. But if anybody asks you that is it always equal, you must say that is not, you in general not equal. We cannot draw any general conclusion, but after if we impose certain conditions, then it may be equal. So remember this. Also, I will, as I told you, some examples will also be after finishing this the syllabus. Then I will discuss uh, some more problems on each topic. And here also I will give you some example where this del fxy equal not equal to fyx. Okay, any more question? And also for your class test, that I have, if I have not discussed anything, I will not give you. But I would suggest you that read all the theories and solve, because if I give a different problem based on Euler's theorem, that I can give you. Okay. Hello.
Sir, class tests are next week.
Next week, yes. Because I would like to take the class test as early as possible, because again I have to examine the all these answer script. So that's why I will take the class test next week.
Sir, please share today's PDF also.
Today I must
Yes, sir.
upload
Thank
also.
you.
Okay, then probably that Lagrange's multiplier also I have uploaded. Only this multiple integral probably I could not.
Yes, sir.
did not
Yes, sir.
upload. Okay, okay,
Sir, till
okay.
sir, set 7, like according,
Set
I mean the
7.
class test.
Okay, I will check. I will go to the to your classroom, and then I will check how many I have uploaded, and rest of the PDF I will upload today. Okay.
Yes, sir, and also, sir, please upload the test syllabus. I mean the
Okay,
name of the topics.
okay, no problem.
Okay, sir. Hello, have anyone done organic lab assignment?
घंटा कुछ नहीं किए हैं भाई।
अरे करना क्या होगा, वो तो सिर्फ कुछ पिक्चर्स है, तो लिखना क्या होगा फिर?
भाई वही तो हम पूछ रहे हैं क्या करना पड़ेगा।
उसमें जो मतलब ऑब्जर्वेशन वगैरह होता है ना, वो वगैरह लिखना पड़ेगा।
इक्वेशन
जैसे
वगैरह लिखना पड़ेगा, इक्वेशन लिख दो, फिर कैसा कुछ फॉर्मेट तो होगा ना। मतलब 12th में जब स्कूल में लैब का असाइनमेंट देते थे केमिस्ट्री में, कुछ मतलब ऑब्जर्वेशन रहता था।
आज मैम से पूछ
अगले
लेना।
क्लास में पूछ लेंगे मैम से, और क्या। परसों परसों तो पूछ ही लेंगे तो कैसे करना है।
अच्छा अच्छा ठीक है फिर। आज आज वो फिजिकल वाला टीचर लेगा, फिजिकल वाला
आज तो
और
फिजिकल वाला लेगा।
हाँ ठीक है।
साले सब पागल हो गए हैं।
Varnav, you
अबे
have done.
सब कुछ एक
Varnav,
साथ पागल हो गया।
Varnav, तो किया है केमिस्ट्री असाइनमेंट?
पागल है क्या? वो जो था ऑर्गेनिक का कुछ यूवी विजिबल स्पेक्ट्रोस्कोपी वही किया है।
আচ্ছা হ্যাঁ ও তো আমিও করেছি, যাই হোক।
আরে বোঝাই তো যাচ্ছে না, শুধু ছবি থেকে কি ছবি আঁকতে হবে নাকি, তাও রং করে করে।
তাও তো ভাই দেখে দেখেই করে দিতাম।
সে তো টুকবো দেখেই, সেটা ব্যাপার নাই। ইন্টারনেট আছে, ইয়ে আছে, সবই আছে, ম্যাটেরিয়ালের অভাব নেই, কিন্তু টুকতেটা হবেটা কি সেটা তো জানতে হবে না।
আর ভাই ম্যাথ এক্সাম নেবে নাকি আবার?
দেখ আজকে হচ্ছে 2 তারিখ, 7 তারিখের মধ্যে তোকে না, কালকে আজকে হচ্ছে গিয়ে তোর কি বার, বুধবার। আজকে রাত্রির মধ্যে কম্পিউটার সায়েন্স আপলোড করতে হবে। 7 তারিখ হচ্ছে সোমবার, 6 তারিখ রাত্রের মধ্যে ড্রয়িং আপলোড করতে হবে। তারপর তোর 9 তারিখ হচ্ছে 9 তারিখ না 10 তারিখ হচ্ছে গিয়ে ম্যাথের টেস্ট। তারপর আছে তোর ইয়ে মাঝখানে আবার মেকানিক্স এর অ্যাসাইনমেন্ট আছে, তারপর মেকানিক্স এর টেস্ট আছে।
মেকানিক্স তো ভাই 13-তে।
যাই হোক অ্যাসাইনমেন্ট তো করতে হবে না, 4টা অ্যাসাইনমেন্ট আছে।
ভাই বহুত চাপ আছে।
আরে অনলাইনে হয়ে যাচ্ছে, তা অফলাইনে হলে তো খতম, টাটা বাই বাই।
अरे एक मीट रख के